to Nicole. All right, thank you, Haley. Like Haley said, my name's Nicole, and I'm going to be the sound director for this evening. What I'm talking about is rigging the sound, the weights, the ropes, the knots, the angles, the do's and don'ts, the outdoors versus indoors, and the speaker setup. All right, so first I'm going to talk about rigging the sound. To rig a speaker, you need this equation right here. It is rated capacity, which equals nominal strength divided by the design factor. Now you may be thinking, what is nominal strength? Well, that is what the structure can hold, the weight it can hold. And then design factor is what kind of design are you holding up? Is it a circle speaker? Is it a rectangle speaker? And that's how you're kind of going to decide how to rig your speakers. An example of this is your design factor is 5. Well, that means your rate capacity will be 1/5 nominal strength. Next thing is going to be shock loading. Shock loading is when you have rigged up a speaker and it becomes damaged. This can happen to a lot of different things, as if it falls an inch or a couple inches, or if it hits another object. An example of this is a 900-pound speaker falls 4 inches. It can have a shock load of 4,500 pounds. Now, I say could because you never know exactly how much shock is going to hurt the equipment. So it's not very easily detected. You're going to have to go figure it out by unrigging it and figuring out the damage. All right, the next thing is center of gravity, which is weight of the objects, and it acts as if it's concentrated. This is when you only need one rope or one chain to hang something. It's just a single point. You need to visualize, especially when you have oddly shaped speakers, how to raise it if you want to have the center of gravity. You always also have to rig above the center of the gravity, or else it's going to slip and fall out of the sling. So here's a picture of above the gravity, or above the center of gravity. And the first picture, as you can see, it's very unstable and it's in the middle. The second one, you can see it's way off and it's below. And then in the third, it's on point. And so that's how you can kind of tell like whether or not you are on the center of gravity or not. All right, the next thing we talk about is weights, ropes, and knots. It's very apparent that you got to determine what kind of ropes and knots you need based off certain weights. Some may need more because of just how heavy the equipment could be. You also always exert a straight vertical pull to prevent swinging and whatnot. You also need to utilize things that are already in the arena. There's usually always speakers in the middle of the arena that you can use to save time to be able to have other things rigged, like maybe the lights or part of the staging. So here I have 2 pictures. One is one that's already installed into the arena. Like I said, most arenas have this, usually there's videos on it. And then the other one's rigged speakers. These are also called flown. It's just the type of rigging that Jamie will talk about later. All right, next I'm going to talk about angles of efficiency. This is basically what kind of angle do you need on the rope to hang the speakers. There are 4 different types. There's 90 degree, there's 45 degree, 30 degree, and then 10 degree. An example of this is if you have a speaker and you want it to be a little lower towards the stage, you're going to use a 90 degree. Now if you want it really high, you're going to use a 10 degree. Here's some pictures of this. This is obviously a 1,000-pound speaker. In the middle you can tell each angle, 60, 45, 30. Also, the more it weighs or the higher you want it up, the less the angle is going to be. All right. Now I'm going to talk about some do's and don'ts of using nuts, bolts, and hanging things. First, you never ever want to attach a speaker to a wall or ceiling. This is because you do not know how much weight that wall or ceiling can hold. You always want to rig it to the equipment already available. You also need to make certain of the strength that you're putting on those support loads. Sometimes it may not be able to carry as much weight as that speaker is and it will fall down. Also, do not rely on nails and wooden threads for support. They're very untrustworthy. You don't want to use something, even if it's easier, because there could cause a safety issue later on. All right, I'm going to talk about outdoor versus indoor sound. Outdoor sound, it's very apparent that there are no walls, which means there's not going to be a bounce to the sound. So because of that, that's a really good thing, but you will need bigger speakers to project the sound. You also cannot rig speakers as well as you can indoors, so you have to put them on tripods, which I'll talk about a little bit later. And then for indoor, obviously there are walls, so you're going to have to rig the equipment due to how the sound will bounce off the walls. It's going to be different at every arena we go to. It just depends on where the walls are and how it sounds. You also do not need as large as speakers, especially if you already have speakers installed, because it's all going to be bouncing, so you don't want it too loud to where it hurts the audience's ears. You can also rig speakers a lot easier indoors because of all the equipment that you can rig onto. Alright, I'm going to talk about large speaker steps now, and the largest speaker that we do rig is the loudspeakers. These are usually flown or on tripod stands. Tripod stands have 3 legs at the bottom, and it's just a stick in the air, and you just hook it onto there, and the reason we use those more than rigging them is because of how heavy they are. Tripods need to be on a flat surface, and they also have to have weights around them to keep it sturdy so the speaker does not fall over. Because of how much these weigh, they are the dangerous speakers we do rig. And that's pretty much tripod. Flown, like I said, Jamie will talk about later. These are 2 examples of tripods. The first one you see is going to be more in outdoor arenas because they do need those bigger speakers so you can hear. And the smaller ones are usually used more in the indoor. Alright, so now I'm going to play a game with you. And the reason I'm doing this game is because as sound directors, we need to understand what kind of sound hurts human ears and how to rig the speakers in certain areas so that we can give an enjoyable concert. So, the first one I have is the human ear is most sensitive to sound that falls between 1,000 HZs and 5,000 HZ range. The second one I have is frequencies above 20,000 HZs are high to be heard by humans. The third one I have is when sound enters the ear, the person is able to stop painful sounds. The fourth one I have is ringing in the ears means you're listening to something that is too loud. And the fifth is sound waves cause variation in air pressures in the ear. So which one do you think is false? Alrighty, you are correct. So these are just some fun facts to know, so when you are rigging the speakers, you can kind of have in your head, oh, maybe that won't be a good idea to put it in that spot. So now I'm going to pass it on to Jamie and Kayla, and they're going to talk about rigging and safety.